record.
This meeting is being recorded.
All right.
Yeah, the floor is yours, Alan. Go ahead. Yeah.
Okay, can everyone see the presentation? It's okay?
Yeah,
Big enough? All right. Yep. Okay, so just a little bit of backdrop. So we've been looking at P4 runtime, specifically for targets like the DPU. And unlike switch, we found some kind of requirement gaps in terms of scale and performance. So as you know, on a DPU, you have much more access to like large tables. There's lots more memory than on a switch, which means that our use cases have slightly different parameters here. And specifically, we have some use cases which have very large tables, you know, and several megabytes of size, like hundreds of megabytes of size of entries. These tables are often exact matches, and they need large updates to all the entries fairly quickly. An example for that is things like VM to VM migration events and things like that. So we started looking at the existing P4 runtime, and specifically, obviously, entry, insert, write, request. And the first thing, I put a little diagram here, you can just see pictorially how the protobuf message is wrapped up. There's an update, an entity, table entry, and then the actual action and field matches. Okay, so with that, we found that the protobuf parsing is fairly slow, or at least when you get to millions of entries, it gets pretty slow because it's parsing it sequentially. It's O of n based on the number of entities, and there's a lot of overhead associated with that. So the message overhead is fairly large. And this is the protobuf. I just took out the piece which applies to this. So what we're looking at, if I remind you, was exact match tables. Okay. So on the left is the current PI protobuf with a message field match and exact value. So we came up with something which we were thinking would be a little more efficient specifically for these type of tables. And we'll call it like a bulk proto. Okay. And pictorially, I can
show. Alan,
yeah.
With respect to the slide before that, so when you say parsing is slow, are you referring specifically to protobuf parsing, or kind of more like all the checks we perform on the server side to make sure that the match field IDs are correct and the values have the correct representation and all that stuff?
So serialization, deserialization, main one. And we did take a look in the PI code for the server side and re-implemented a few things just to make it a little leaner. And that also helped. So there was a kind of like an onion, peeling an onion. The first part, which was fairly large, was the serialization, deserialization. And then there was some contribution to the performance based on just the server side code. Yes. And I can go over, so a little more about this particular use case is more like when you have a local P4 runtime, I'll call it client, which is actually on the same host CPU. It may be running as a different process. Some of the things which we didn't need in the PI stuff was like like the you know, the arbitration and the election and a whole bunch of stuff like that. All we really needed was a very fast way of getting entries in. Okay.
I see that either Stefan or Jonathan has something to say.
Yeah, just quick follow-up questions also on the parsing speed. So here you're saying parsing speed is O of n, which, you know, is kind of I mean, that's the best you could possibly hope for, right? So is the point more here that, yeah, I guess I just wanted to understand this a bit better.
Oh, okay. So
the parallelize or?
Yeah, so this is all wrapped up in one update. So you'll need multiple updates, right? So let me just jump to the slide. Okay. So the idea was we actually came up with a like a set, an update set now, an entity set, a table entry set. And there, for a specific table, you can now pack in all the entries which you want to update or add, insert. So that takes it's basically moving the concept a little further down. So you don't have all these entities and all these tables. You have a table entry set which has all of your data in one place. The advantages of that was, like I said, wrote here, there's a table action set as a container. So the number of messages does not depend on the number of entries anymore. And basically it's an array of values. So it's also faster parsing and a little more local in memory. So I know the P4Runtime and protobuf tries to do a lot of performance optimizations using different allocation schemes. You know, I saw some, you know, where we're using Arena or TC malloc and things like that. That's because the data is scattered all over the place, and there's a lot of like mallocing going on, right? So the idea here would be, in this particular use case, when we're updating one table with a ton of entries, we can pack all the data into one entry set. Okay, and that parses a lot faster.
Okay, can you go back one slide?
Yeah.
For the messages. So do you use one byte array for all the fields in one entry, or is it for fields across multiple entries? Because it looks like it's for fields for one entry here, right?
Fields for one entry. Hang on, what's
yeah, I mean, I think it's based on the table entry set. Maybe not all the changes are here.
Yeah.
But I think when you were talking about table entry set, do you have one table entry set message for multiple match action entries, or are you still gonna have individual table entry messages for the different table entries you're trying to insert?
No, it's one.
Okay.
Okay. All right, and you can see in the example of it, in this case, this is an example with one action. Sorry, the same action. So the values for in this diagram are for a field match set with the same action. And the thought was on the second one is, if you want to support different actions, there's a couple ways of doing that. And this, I'm not, you know, this is definitely open to different ways of doing it, but this was one thought that we could have, we could split into, like I said, a set of shards. And this is a big trade-off between size and speed. So you can see here that there are, if I have like one action ID, then I might use values like 1 and 2, versus if I'm using a different action ID, I might use action slot like 3 in this one for action ID 2. And that does waste space, but it makes it, that's one way of speeding up the access and supporting multiple different actions in the same table.
In a way, it's also a bit reminiscent of the PIC implementation, because you're packing all those fields into contiguous memory into one byte array, and then you access the different values at different offsets. But essentially, there's only one big memory buffer allocated, I assume.
Yeah. So I'm guessing a large part of the savings is actually that all that allocation is no longer there. And also the just it's faster to parse, obviously. So there's memory locality. It's packed into a kind of a byte stream.
So Lob, what you are saying is basically have array of keys, and then for each field that has been modified on any of the table, that field will have an array of values, and each entry corresponds to the list of keys that was packed before, and so on and so forth, right?
For this, yes, for this example, yeah.
Okay. And you have the experience that this will. I'm just trying to see how is that going to optimize, but there should be some improvement.
So what we primarily tested was this one, which is just one action. So since it's one action, it has the same set of values for its action parameters, and everything packs in really nicely. This shouldn't be much different, right? Because it's all just offsets into arrays. There's no searching in that sense.
I see.
I have some numbers if you're curious. So we started. Yeah,
Sorry, one more.
that's all right.
Just so I understand one more slide.
One more slide. Okay.
So what would correspond to a single table entry here? Should I think of this as being basically a row in this field match set, and both of the field match sets, like you're essentially now distributing them? Is that what's going on?
Yeah.
Okay, great. That makes sense.
So you would have like many rows of this, like a million of them, and that's what I can't remember, but there was a decrease in the actual, like if you looked at the protobuf message size, I think it was a factor of 3 less data in general. You know, if you just took the size of the entire message that was being sent.
Right. Well, now because now I don't have a million field match, message things. I just have one field match or X field match sets, I guess, however many keys there are, and then entries filled in. Yeah. Okay,
Yeah.
makes sense.
Okay. So
Alan,
data's less.
Sorry, one quick question. Does this mean that all the entries have the same the same table ID and the same action ID?
Table ID. In this case, it is the same action ID. In this example, it's the same table. So we're always talking about one table. I want to update one table with a ton of entries. So that's this case. The one with one table with different actions is this slight modification. Okay. So we're taking advantage of the fact that you have a table. The key set's going to be the same, but action parameters might be different.
Right. And now, how do you encode wildcards for matches? Because normally that's
we're not doing wildcards. This was just exact.
Yep. Cool. All right.
Okay. Yeah, that would be an interesting thought to see if it can expand to, optional or ternary. But right now, our main case was trying to get the exact match tables, which are super large, like in the millions, to be able to update faster.
Right. Makes sense.
Okay.
There aren't many implementations that support ternary or optional with millions of entries. Yeah,
that's exactly. If you have a TCAM which can handle that, good for you. Okay, so and I don't remember the exact architecture for the x86. It was done on one of our servers, which was a couple of years old, so it's not like it's the one after Broadwell, I think. So it's relatively fast. So let's take a look. So we measured just the gRPC performance, the C version, using Arena on an x86, and we got close to 1 million operations per second. And then we ran it on our Bluefield 3, which has an ARM complex. So that's kind of what we're interested in is the ARM, which is obviously a little slower. And then we measured it on just going through the whole libpi, okay, where it's already deserialized. So this is where Anthony and I mentioned there was some performance related changes we did to libpi. So this is actually not the libpi straight out. This is the libpi where we kind of replaced a few things, got rid of some of the, I think we replaced the hash and a few things like that.
I think for many people, maybe this is a bit abstract. I think you're still building protobuf messages in this case, but you're using a client in the same process. Or can you clarify what you mean here by libpi?
Okay, so it's a server side. So we linked against the libpi, the PI library, right, to build the P4 Runtime server. So
Yeah,
now
okay,
this
but but you're still going through protobuf, right? It's not, you're not invoking the C function.
yes,
Yeah.
yes, right.
As opposed, and in the gRPC case, you're using gRPC, but you're not doing anything with the messages on the server side. Is that correct? Or
Yeah, so it's kind of a measurement of without the gRPC layer on top.
okay, but I'm just trying to understand why it's lower than the gRPC one. And I guess it's because in the gRPC one you're not doing anything with the messages in the server.
Right. Yeah,
Okay.
the messages are just thrown out. It's a deserialization measurement.
But just to confirm, at least in the gRPC case, were you using batches, for example, like pretty large batches, or how do you get that number? By which I mean, I assume you were sending multiple table entries per write request, right?
Yes. That's a good point. I forgot what sizes we played with. There was a limit in the we stuck pretty much with the configuration that came with the PI. It had the gRPC was set with a certain max.
Yeah, there is a limit of I think 4 megabytes.
4 meg. Yeah, that sounds familiar. So we
yeah.
we stayed within there, maybe a little bit below. We didn't play too much with the message. Sorry, someone else has played with that was working on this in a slightly different context, and I can talk about that later. But there is an optimal size. Yes, we did find a kind of a sweet spot.
Yeah, I think after sometimes you don't get any more gains anyway, but putting more entries.
Yeah,
which makes sense.
So Alan, these are the results from your bulk APIs, right? What was it like before you did that? In other words, to do the same number of table entries, what were the times? Do you have a comparison?
Okay, just on x86. So this would be the comparison. Almost a factor of 10.
And this, again, sorry, I know your slide already says this, but so this is not parsing. This is the actual processing of the tables. Just
no, it includes it includes serialization, deserialization of the protobuf messages.
Yeah,
but there is no gRPC. I think maybe I'm wrong, but I think you're calling directly into the what is called the device manager interface in the PI repo, maybe, which is a C++ interface that takes as input protobuf messages, but there is no server component. That's yeah.
Wait, so then, because it says already deserialized here, so are we taking in the protobufs as a a C message, or is it...
sorry. I mean, sorry. It's already come in from, so it's
okay.
already like it's we're not measuring client side. How do I say that? Okay, it's just the server side processing. Sorry.
Makes sense. Got it.
Okay. So this is our preliminary results, and this is something which we're wondering whether this is something that the community would be kind of interested in. I don't know, getting it in there or getting it cleaned up, so it's a little, usable by more than just our use case. I mean, some of it is definitely tailored towards the exact, but so yeah, the tailoring is towards exact tables and single table updates. So,
well, Alan, I just got out of a Dash working group meeting on high availability. And there's use cases where you have to like populate a table, a huge table, right? Millions and millions of entries, and not everyone's necessarily going to use a P4 implementation or P4Runtime. It's the Sonic Dash is really going to be using Psi,
right?
But some people will be using P4 underneath, and I can see how there's going to be need for optimization when you have 10 million entries for let's say a failover situation or a planned failover.
Right. Yeah, so, that's what I meant. It's definitely coming from these type of DPU use cases on the edge where you're connected to a hypervisor and you've got tons of table entries to update.
Yeah, like 10 million, right?
Yep.
scale is enormous.
So the question I have for the group is this something that we think we want to take P4Runtime in this direction where we'll have less generic APIs but higher performance. So like definitely when replace, if you want to do it the other way, you can still do it the other way, the standard way.
Does it have, yeah, can it just be yet another RPC that this just enhances the current APIs? We don't have
like
non-breaking enhancement, right?
Yeah, right now we broke it by just kind of overwriting what was already there, but it would be like adding a new message type completely.
Every API comes to this point. I mean, even SNMP had bulk set and get, right? Yuck, but that's our legacy.
All right. So any comments or feedback there?
I feel like it could make sense as a different entity message, like table entry bulk or something like this, or table entry set, to use the same terminology as you. And I think this, it seems you're only interested in kind of having those changes for tables, maybe even exact match tables, and not at all other other P4Runtime constructs like stateful registers or things like this.
But do you think we should try to make sure if we come up with a general solution, it could be applied to other entities? Like what if someone wanted to, I don't know, set or get some huge array of statistics or something? Would there be any equivalent? Is that already kind of efficient? Let's say you wanted to get 1 million counters. Is the current API, I haven't looked at it in a while, does it handle that efficiently, or is that also kind of full of lots of wrappers and padding?
I think it would be just the same problem, right? Because it's per entry. You'd have to get all the entries, right?
Yeah, I mean, yes and no. I feel like counters is kind of like a different beast. Yeah, you do have to get all the entry, but it's a very small message. And like the counter value is like a 64-bit integer, so it's like there isn't all that string serialization, deserialization happening. And also, I think protobuf represents like integers very efficiently in terms of space usage. But I feel like we could start with tables. I think this has legitimacy in the sense that how many people, I mean, I feel like most people actually end up having wrappers around P4Runtime. So in a way, it kind of like, does the P4Runtime interface itself needs to be super friendly if people have like either auto-generated wrappers, I think in the case of Google, for example, or anyway, it's used as part of, there is a library built around it. I think in the case of Onos, for example, please guys correct me if I'm wrong. So I think there is value in making P4Runtime as efficient as possible if it's used kind of like really as a message transport mechanism and not something that applications necessarily integrate with directly.
I guess one more question, sort of as a PL guy, I have to ask this. So it seems a bit unfortunate that, well, I guess the one question is like, how much have we played with proto parameters, sort of like optimizing this under the hood instead of changing the actual abstraction that we're using? I don't know how much information there's out there on optimizing protos. I know we have a bunch of, like, some of this information is internal at Google. I'm just wondering, like, how is there opportunities for like optimizing performance without changing the representation? Have you looked into that at all? And I don't know the answer. I'm just throwing out the question.
We've looked a little bit, but not quite on those lines. Hey, Melinda, I see you're here. Melinda is on my team. He's looked at optimizing some of the infrastructure underneath you want to describe a little bit what you're doing, Milind?
Sorry.
Yes. But before we go there, to answer Stephen's question, Alan, we tried using the arena allocator and things like that, right?
Yeah.
That gave a little bit of boost, but not a whole lot. And we have profiled it. What we see is a lot of time is spent in actually memory allocations and deallocations and some stringification and on string to int into string and those kinds of things. Most of the time is spent there. Like I'm doing something advanced orthogonal. I can just suggest it. Right now, it's still not fully baked. Where whenever we have both the client and server on the same DPU kind of environment, we don't have to go through the entire protobuf gRPC stack. What I've been fiddling with is we produce the protobuf, but then we use the shared memory underneath to just push that. We serialize them into C struct and then put them into shared memory buffer, and the consumer just plucks that data out of there, and that's been showing a lot of promise. Something like of the order of 25 million entries per second.
Yeah, so we're looking at kind of two directions. One would be this would support any remote P4Runtime controller just in a much more efficient way. And what Milind's looking is to make it even faster if I'm local on the same CPU complex. I might be in a different process, but can we even make that even faster? So they're kind of complementary things. In fact, I wonder if this work okay, I'll stop there because there are kind of two separate things which we're investigating. Milind's just preliminary stuff on the shared memory stuff. Okay.
So Alan, the way you are recommending to pack these table updates, do you think we'll get into a situation where one entry may require multiple updates on the client side to get all the changes in? So for example, let's say you have 10 million entries that is getting updated. Now, if you want to have this 10 million keys as an array, and then you will select, let's say there are 100 fields that got updated. So maybe you will be able to pack only 50 of the attributes. And then you again go to another message that you have to send from the server to the client. And the rest of the 50 attributes will be packed in the second message. So something that was supposed to be, or which is being taken care in one update for a particular table entry, now it will translate into two. Can this be a problem or anything?
I'm not sure I understand how you got two entries out of that.
Yeah, I'm just playing with the size, right? So you will have max buffer that you can pack into a message, right? And so if you have million entries, million keys that is getting modified, and 100 fields are getting updated for each of them, and only 50 of them you can pack into the message, 50 times whatever 10 millions, right?
Wouldn't it make more sense to split the table horizontally in fat chunks than vertically? Kind of talking about vertically.
Yeah, correct. So I mean, that's, I see.
Just do 5 million entries with all the fields, right? Seems like that's a bit of an artificial problem.
Yeah, that is something can be done. Yes.
I mean, you could chunk it.
So we thought about further optimization, but this gets a little more complicated. Like if I had a table with 1 million entries, each entry needed to be updated, but only one field, like one parameter, needed to be changed, then we're actually sending a lot of redundant data.
Yeah.
That's getting the next level of complexity, right?
Yeah.
To basically do a diff.
I wouldn't necessarily shy away from being a little more complicated than sending a whole sparse set of action parameters, right? Because we're putting the effort into optimizing this. I'd go a little bit further, like you just hinted at. It seems like okay, you just want to update this column on all tables.
Yeah, exactly.
Right. I mean, that's a real world use case.
Right.
You're going to go from 1 second to 1/10 of a second by doing that. It's
like
worth thinking about.
Yeah, like in the VM migration case, it could be just like one, source IP address, and everything else is the same. All right. So what is the kind of the next steps here if we want to kind of make this more of a formal proposal, if everyone thinks it's a reasonable idea?
Well, I would say.
Oh, go ahead.
I would have said a pull request with like kind of like the new entity types that that would be able to support that kind of a batch table entry update, just so that everyone can see the exact proposed protobuf message definition for that.
Okay. All right, we can definitely do that in the next few weeks.
I think you wanted to present that at the P4 workshop too, or?
Thinking about it, but I'm not sure it's quite there yet. That's all.
PFP date's already passed.
Yeah.
It's 13th. The 13th.
Yeah, I know.
Not that that's a hard stop, but
yeah,
I've seen a couple trickle in after that.
So yeah, I think we might want to get a little more solid data on this, and but the first step was to run it by everyone here, just see that no one sees has any large objections to the idea.
I had, sorry, one more question, and maybe this is a good one for Stefan or someone with more of the exposure into protobuf. But is for sort of arbitrarily structured data, I think protobuf is sort of a pretty good abstraction. It seems like in this case though, like all we want to do is push like a fairly well prescribed table across the wire. And I'm wondering if like there are better abstractions than protobuf for doing that. Because I mean, it seems like what you said, the memory locality is inefficient, and mallocs and freeze are inefficient. I mean, is there a better RPC mechanism if you just want to dump an entire table across? And then maybe there could be some pre-handshake where you specify sort of the template or schema for the entries that'll appear in.
I mean, it's sure that if you just end up with a protobuf message that wraps a byte buffer, was like where you've encoded things in a certain way, then yeah, using protobuf doesn't bring you anything. Right?
Yeah. I mean, I don't necessarily want to go down the OpenFlow path where like we're defining things at the byte level. I think that's sort of inefficient, and then it requires a bunch of clients to implement things in precise ways. But
there's a bit of that in Alan's. Sorry, go ahead.
So I've been reading a little bit on our internal resources about protobuf performance in the meantime to learn a little bit what they say. And I mean, they're basically saying hierarchy is expensive, which is exactly what I think Alan observed. So if you want it to be more efficient, you have to remove some of the tree-like shape, right? So you have to make it more flat. If you use repeated fields, those should always be packed. So they should be packed in memory. And so I think you can still use protobuf. You just need to give up some of the hierarchical structuring if you want better performance.
so maybe my comment then could be amended to say like, we can still use the protobuf structure to define maybe 1 or 2 or 3 templates, and then maybe consider even promoting the table data that Alan's presented to like an even higher point in the hierarchy, so that it's not sitting down like 3 or 4 levels. And if we had sort of a generic bulk table update where there's maybe some sort of entity ID, I don't know, I'm just sort of, I haven't thought this through very well. So except there may be tons of holes here, but just from a brainstorming perspective, I'm wondering if we can make the approach that Alan's presented even more generic, embrace this row column format thing, and then figure out a way to map a standard table entry to this row column schema.
Yeah, you could have an update message that first has some metadata describing the layout you're about to send, and that might say, here's the columns that I'm going to send. Right. And both match parameters and action parameters, right? So it's sort of like marking what I'm about to send, and then you could blast a very efficient blob.
In that case, we could still use existing server logic to do validation. We could validate that, like for a given table entry, there's the right template, meaning the right match fields, the match fields are the right shape, the right action parameters, the right number of parameters, stuff like that. But then it would sort of be that entry serves as sort of a template for bulk processing. You only have to send that once. I don't know. Again, just spitballing here.
I wanted to bring up one topic. These field values and match action values, wherever there is value, they are all stringified rather than like, you know, a 32-bit int or something. And that leads to dynamic memory allocation, int to string conversion, and then string to something blob or something conversion. That seems a little wasteful to me. It's been done to be super generic, but if we can make those types not be converted to strings, it would be much faster.
Is that a feature of the protobuf compiler itself? That's what it generates?
Yeah.
Okay.
I mean, that's what it generates for the bytes protobuf field type, which we use because we don't, I mean, that's P4, right? So we don't know the size of the field.
Yeah.
But yeah, I like Brian's perspective on this, but I think we should maybe see the full proposal by Alan and Milind as protobuf changes, and then maybe we can iterate on that.
Okay. Okay, that sounds like a good start.
Yeah.
Okay. I'll try to get something cleaned up and put it in pull request, and everyone can take a look and make comments of whether we want to change the structure more or whether this is a good enough structure.
And yeah, it would be great. Maybe we'll have some comments, and I mean, ideally, if we converge on possible alternatives, I assume you guys would be able to benchmark this in the same conditions potentially. Yeah.
Yep. Okay.
And anyone else has a question or a comment for Alan and Milind?
I guess just thinking through this, and you know, I think this is one sort of super interesting use case, which is the huge tables. But there are other areas where we've had some amount of struggle for performance in the past. The big one I can think of is packet ins and outs. And in those scenarios, applications that have required performance have effectively pushed their solutions out of band, meaning off the protocol channel. But yeah, I guess if this is sort of a successful approach, and it has a 10x improvement, then maybe there's a new set of use cases that could be served, in some of the other areas where there's been stuff pushed out of band. So I think if we can find a generic solution, or at least a template or framework for applying this optimization, that could be interesting in other parts of the protocol as well.
We probably ought to also be mindful of other domains. Like this is sort of a SmartNIC edge kind of a case and that prompted it, but there's probably related cases like that, all the discussions going on, the IPDK, the OPI, P4, DPDK, all these areas that are starting to simmer and froth. Hopefully people in this working group have some exposure to those and can think about that as well. So we don't just solve one kind of corner case. Since those projects will sort of inherit a lot of the P4Runtime working groups, efforts, whatever we choose here.
Okay, sounds good. All right, so it'll be on us to get a pull request up with the details, and we'll go from there.
Yeah, that sounds great. Thanks, Alan. We
Right.
appreciate you presenting this to us today.
Yeah.
All right.
On short
Thanks.
notice. Thank you.
Thanks for setting up an extra meeting. Okay. All right.
Yeah,
Bye,
thanks
guys.
for joining, everyone. Have a good one.
Thank you.